Back. Now we are working on problems from section 2-4 from web work. First question. Evaluate the limit x approaching 0 sine 4x over 8x. Sine 4x over 8x. Right? So I will move the 8 aside first. Whatever is the argument inside must be the argument below. So I moved the 8 away, replace that 8 by 4. Whatever I write below, multiply below, I must multiply above. Okay, so notice this expression is essentially the same as expression if you cancel the 4's, right? So 4 by 8 is a constant, so it comes out of the limiting process. Now you have limit x approaching 0 sine 4x over 4x. So as x approaches 0, 4x also approaches 0. And note, the same argument for sine is in the denominator. All right. So this limit is 1. Answer is 4 over 8, which is 1 over 2. Next. Limit x approaching 0 sine of 6x over sine of 7x. All right. 6x, 7x. Notice I need the same argument. So let me rewrite this expression sine 6x over sine 7x as follows. I moved the sine 7x here, sine 6x there. Whatever I had the argument, I wrote it below, right? Because I wrote it here, I write it here also. Now likewise for sine 7x, I have that argument, so I write it above. Because I write it above, I write it below. So notice, if you actually cancel things out, this cancels this cancels this, and you're left with the original expression. Now at this point, notice x's can be cancelled. These x's. So what am I left with? This constant 6 over 7 outside, and limit x approaching infinity of this fraction and this fraction. This goes to 1, this goes to 1. Limit is 6 over 7. Next problem. Limit x approaching 0 tan x over 3. Tan x is sin x over cosine x. Okay, so tan x over 3x is sin x over cosine x. That's the numerator over 3x. So notice numerator, and this is being divided, so that stays in the denominator, and you have sin x over cosine x. All right. Now as x approaches 0, let me rewrite this expression as sin x over x separate, 1 over 3 separate, and cosine x separate. When x approaches 0, this 3 is unaffected, so that's 1 over 3. This is 1, and this is 1 over cosine 0 is a 1. All right. Remember, cosine of 0 is a 1. So all that gets me 1 over 3. Next problem. Let fx be 9 sin x plus 4 cosine x. Find its derivative. Well, it is 9. What is derivative of sine? Cosine x. Plus 4. What is derivative of cosine x? Negative sine x. So I introduce a negative there, and then sine x. So remember, derivative of cosine is a negative. That's where that negative came from. Now I want to evaluate all this on 5 pi by 4. So all I do is I replace the x by 5 pi over 4. 5 pi over 4. Okay. Next problem. fx is this function, find its derivative. Derivative of cosine is negative sine, so I get negative 3 sine x minus 3. Derivative of tan is secant squared x. Alright, and I'm going to evaluate all this at negative pi over 4. Okay, there is a negative pi over 4. Negative pi over 4. Alright, next question. Fx is this function, find its derivative. So notice there is an x over here. Alright, so what happens is, this calls for product rule. So I will say negative 3. Derivative of the first, that is 1. Second as it is. Minus first as it is. Derivative of the second. Derivative of sine is cosine x. Derivative of cosine is minus sine of x. Okay, and I'm going to evaluate it all that in pi over 6. Don't forget there is an x over here. Okay. Next question. Well, again, this is product rule. You have 3 factors. Derivative of the first, the rest as it is, plus first as it is, derivative of the second, third as it is, minus first and second as it is, and derivative of the third. So notice that minus is because derivative of cosine is a negative sign. Alright, so all this gets me, let's write it here, 2 sine x cosine x plus 2x cosine squared x. You see, 2x cosine x minus 2x sine squared x. All right, and evaluating it at 3, that's it, 3, I have to write 2 times 3, that's a 6, 3 and 3, oh, I forgot this, 2 times 3 is a 6. All right, this problem will start on our next video. Until then.